So let us go ahead and also solve part D, which is the most interesting question so far. So from the question where we have been told that given that n is a positive integer, for part D, so we need to use the first principle to differentiate what we have here. But we know, guys, that using the power law, we drop the power, you keep this constant, the power reduces by 1. So we should go ahead and find this to be the final answer, but we need to use the first principle. So the first principle states that limit as h approaches 0 of x plus h minus f of x, divide this by h. Okay, now one thing should come in our mind is that where there is x, we are going to replace x plus h. So I'll have limit as h goes to 0, and then I'm going to say x plus h, but it is raised to the power n, minus the original function is x raised to the power n. I divide this by h. But now how can I expand this? So I can expand that using binomial theorem. Okay, because we've been told that x is greater than or equal to 0. Let's just put it that way, because it's a positive integer. So hn cannot be negative, so I'm going to use binomial theorem. So there we go. What we're going to do is this. So what we have now, guys, is this. We're going to have I'm going to expand this using binomial theorem. So how do we use binomial theorem to expand that? Let us see. So one thing we should know, guys, is if I have got n, let's have this a plus b. I'll take you back to binomial. I'm sorry. So this is going to be n, choose r, then a raised to the power n minus r, then b raised to the power r. So it keeps on going. Where r starts from 0, we know that it's going to be n choose 0 until r reaches at n. So I'll put it here. R has to start from there. That will be the start. Then the last term, r has to be equal to n. Why am I doing this? Let's assume that n was 4. I would have gone to n choose 0. I do, then n choose 1, n choose 2, n choose 3, n choose 4. You get it? So now what I'm trying to do now here is I'm going to expand now this. So now x is a is x, then that is that guy. Okay, so what I'm going to do, allow me to do this one. I start from this point. I'll say x plus h raised to the power n. So what are we going to have? The first one, using the same thing here, I'm going to say I'll start from n, choose 0. R now is 0 because we're starting from 0 all the way to n. Then a is x, now n minus 1. What is my b? My b is h raised to the power 0 because r is 0. Okay? Now, the next thing is going to be n. Okay? I'm going to say n, choose 1. Okay? I'll say n choose 1. Then what I'm going to do, if n is choose 1, so I'm going to have this n choose 1, then I've got x. Now it's going to, so this is supposed to be 0, sorry, n minus 0. Then this is going to be n minus 1, then h raised to the power 1 plus n choose 2, then it's going to be x, n minus 2, h raised to the power 2. So this will keep on going. We don't know where it's going to end. I'm going to say it's going to end at n choose n, of which this one is going to be x raised to the power n minus n. In this case, r is n, then h raised to the power n. Now end there. Now what happens here is this. What happens, guys, here now is this. What are we going to do? Let us try to simplify this. If I have n choose 1, what is the answer here? We know that it is n factorial, then n minus 1 factorial times 1 factorial. But I'm starting with 0. Let's not confuse ourselves. So I want to start with 0. If I'm starting with 0, then it is n factorial divided by n minus 0 factorial 0 factorial. One thing you should know is that 0 factorial is 1. So we have n factorial divided by n minus 0 is just that. So that and that will cancel or remain with 1, meaning that everything here is 1. This is 1. But again here there is 1, but x to the power n minus 0 is just x. So 1 will not affect anything. I'm going to have x raised to the power n. H to the power 0 is c. N number to the power 0 is 1. I'll leave it there. Plus. I'll go to the next one. So the next one is n choose 1 is going to be n factorial divided by n minus 1, then 1 factorial, here also factorial, of which for me to cancel factorial, the n minus 1, when I have n, same as, let me start with 5. If I have 5 factorial, it's the same as 5 times 4 times 3 times 2 times 1. So as you can see, it keep on reducing, meaning that n factorial, it will keep on reducing. N, then here is n minus 1. But since down there I've got n minus 1, I'll put factorial. So then it's going to be n minus 1 factorial divided by n minus 1 factorial. 1 factorial is 1. These will cancel. I'll remain with n. Meaning this guy now is just n. On top there I've got x raised to the power n minus 1, then h raised to the power 1. We go to the next one. So the next one is going to be the next one, guys, is 2. N choose 2. So it is n factorial divided by n, then I'm going to have n minus 2 factorial times 2 factorial, of which this one I can also reduce. It is going to be n minus 1, n minus 2, then I end there factorial, so that it should come and cancel out with this. So these two will cancel out, and I'll end up having n minus 1, but down here 2 factorial is just 2. So I'll have n. So n I can do is same as n times divided by 2, like that. Then I say n minus 1. Then this is now x raised to the power n minus 2, h raised to the power 2. So why am I going to end there? Then I just put plus, then I end on n choose n. Because I can clearly see that. That's why it's basically important for us to differentiate first using the normal. I know that I'm supposed to go and end there. This guy. So once I have this, then I need to have the next one, which is going to exist where I need to have h. So that when I factor out x, h should exist here. So that when I plug in h, it's going to give me 0, meaning this one, everything will go. Let us see. So I'll say this is plus, then plus, what is n choose n? N choose n is n factorial divided by n minus n factorial times n factorial. So it will be n factorial. N minus n is 0. Then I'll end up having just n factorial. Everything will cancel out. I'll have 1. So again, n minus 0, n minus n on top there is going to be 0. N number to the power 0 is 1. So 1 will not affect anything, meaning this side everything has gone. I'm meaning with h to the power n. So what I have here is the one I'm going to place with the top part. I'll go ahead and say limit as h approaches 0. Where there is this, now I'm going to replace x raised to the power n plus nx raised to the power n minus 1 plus n over 2 n minus 1, then x raised to the power n minus 2 h raised to the power 2 plus, we don't know where it is ending, then plus h raised to the power n. But we have got minus here. Let's not forget minus x raised to the power n. Everything we divide it by h. I'll divide everything by h. So let us see. This guy and that one can go. What I've remained with, limit as h goes to 0 of nx raised to the power n minus 1 plus n over 2 n minus 1 x n minus 2 h squared plus, we don't know where it is ending, h to the power n divided by n. So here we forgot there was h. If I remember very well, there was h here, guys. Let's not forget. If I go back here a bit, just let me go back, I show you. I've forgotten h where there is n times x. I'm supposed to put h. Okay, here, this one. So I'm supposed to include it there. So that's why I was saying here I'm supposed to put h. So I now get rid of this. I divide it by h. So remember here there is n raised to the, or x raised to the power n, the one we cancelled. So this and that will go. Remember there is h here. So we have limit h goes to 0 so n, then I have n plus 2. I'm just copying that. I divide it by h. Now we can factor out h on top. Even without wasting time, when you factor out h, it's the same as cancelling this h because h is everywhere. Here I remain with 1h. Here also 1h. So I have remained with limit h goes to 0 of nx that plus n over 2 n minus 1 x. I have that. I've remained with 1h plus h. So if we are to plug in the values where there is h, we put that, we'll have that. I'll have this. So that will be 0. Then plus here 0. 0 times everything here will be 0. Therefore I'll end up having nx that becomes my answer, which I found there. So using first principle, just follow it step step by step to be easy for you to remember. Okay.